This is the accompanying video for the paper Automatic Error Recovery in Robot Assembly Operations Using Reverse Execution, submitted to the IOS 2015 conference. We here present our work on applying the principles of reversible computing to industrial robot assembly. Traditionally, when assembly tasks are automated, a large amount of work is required to ensure that everything behaves deterministically. This is in general an expensive process and requires many customized components. Many errors are however probabilistic and arise due to small uncertainties. If we could simply backtrack a few steps when an error occurs and then repeat the assembly operation, the errors would in many cases fix themselves. We propose a solution where assembly sequence programs are designed such that they can be executed both forwards and backwards, resulting in either an assembly or a disassembly. When encountering an error, we are therefore able to change the execution direction, step back through the program, and repeat the operation. And due to the probabilistic nature of the operation, doing so will often fix the error. This idea is what we see in this demonstration. The robot is trying to insert a screw, it fails, backtracks in its program, and repeats the process. It does this twice before the error is fixed. Rather than a naive, state space backtracking approach, our underlying approach is to make programs that are executable in both forwards and reverse direction. The developer writes the assembly program in a domain-specific language, which is styled to look like a normal robot scripting language, such as the KUKA robot language. Our language is based on the principle of local inversion. The norm is that there exists an inverse for each step in the program, and executing these inverses in the reverse order gives us backtracking, or more general, gives us automatic disassembly. A simple example is that a command for opening the gripper becomes a close gripper command. Through this approach, we are able to reverse most of the assembly process. We do, however, also allow the developer to override the default reverse behavior with an explicit reverse implementation. This unique feature enables reverse execution to still be applicable in real-world situations where assembly and disassembly are not simple inverses of each other. For instance, the reverse of a complicated peg and hold operation is simply to pull out the peg. This same approach, of course, allows a complete assembly sequence to be executed both forwards but also in reverse, meaning that we can completely disassemble an object based on the description of how to reassemble it.